Alright, let's go ahead and get started. Today we're going to be talking about rational numbers, and our objective is to learn to write rational numbers in equivalent forms. And a rational number is basically a fraction of decimal is typically what I'll be talking about. Alright, our vocabulary words for today are rational number and relatively prime. A rational number is any number that can be expressed as a ratio of two integers. That should be ratio, not ration. So whenever you guys are copying that down, you can go ahead and get rid of that n. Should be ratio. Here, let me see if I can. There we go. And relatively prime are two numbers that are relatively prime if their greatest common factor, their GCF, is 1. Alright, let's take a look at our first example here. The first example says simplify, and it says 16 over 80. Okay, and what it's talking about is it wants us to write this in simplest terms. Okay, so we need to look at our numerator and our denominator and ask ourselves, well, what number goes into both of those evenly? Now on this one we know that 2 will go in there because, well, they're even. So if we divide both the top and the bottom by 2, that will give us 8 over 40. Now, 8 and 40, again, are both even, so we can, again, divide both those by 2, which will give me 4 over 20. And again, those are even, so again, we can divide both those by 2 again, which will leave me with 2 over 10. Almost there, but again, I can divide 2 over 10. 2 will go into both of those as well, which will leave me with 1/5. And 1/5 is our answer. Now, we could also say a shorter way to do that is if we realize there's a larger number than 2 goes into both those. So let's take a look at that 16 over 80 one more time. Now I can tell you by looking at those, I know that 8 will go into both of them, so if we divided both the top and the bottom by 8 to start with, that would give us 2 over 10, and then we could simply divide those by 2 that time, which will give you 1/5, which is the same answer that we got right here, just in fewer steps. Which, if I can make it quicker, I'm going to, because I want to get it done as soon as I can. Alright, so let's take a look at our next one. Next slide again is the same type of question, has our fraction, wants us to simplify that into simplest terms. Now, by looking at this, I have negative 18 over 29, and I'm looking, and I notice that 29 is actually prime. Okay, so 18 and 29, you could say that those are relatively prime based on our vocabulary earlier, and those in lowest terms are going to be 18 over 29 because no number goes into both 18 and 29 except for 1, which gives me 18 over 29. I guess I should say negative 18 over 29. And we simplify that. That one's done. Alright, the next screen here says decimals that terminate or repeat are rational numbers. To write a terminating decimal as a fraction, identify the place value of the digit farthest to the right. Then write all the digits after the decimal point as the numerator with the place value as the denominator. Now, what does all that mean? Well, let's take a look at a slide and I will tell you exactly what that means. Now, what it's telling us to do is it's telling us to identify the place value, like in letter A, of the number farthest to the right, and in this one, it's 5. So, we have to identify what place value that is, and well, when we do that, we notice it's the tenths, hundredths. So since that's the hundredths, we would simply put 75 over 100. Now, you might be asking, well, what do we do with the 8? Well, the 8 is a whole number. That goes in front of my fraction. So this would be 8 and 75 over 100. Well, I need to simplify that into lowest terms, and I know that 25 will go into both 75 and 100. So that's going to give me, what, 3/4? So I know that my answer is going to be 8 3/4. I guess I should write that right here, huh? Easy enough. That one was. Let's take a look at letter B. Letter B is a little bit more difficult because, well, the number is much bigger. So let's, again, the first thing we need to do is identify the place value of, and this one is going to be the 5, the digit farthest on the right. So let's figure that out. Tenths, hundredths, thousandths, 10,000ths. So when we're going to write that as 2,625 over 10,000. Now that fraction looks pretty mean to simplify, but since I have a 5 and a 0 here, I know that 5 will go into both of those, so I'm going to start with a 2625 and divide by 5 to simplify that. I know that 5 goes into 2 0 times, it goes into 26 5 times. Left over 1 goes into 12 2 times. Goes into 25 5 times. So I'll get 525 over, so let's see, it's going to leave me with 525 over 10,000 divided by 5 is, what, 2,000? Alright, well, I know that I can simplify that again, so let me make some more space. Let me erase this here so I have some more room to do some more work for you. Alright, so let's work this guy out. And I know that 25 will go into both of those, so if I have 525 divided by 25, let's see. I know that my top number there is going to be 21, and let me see, 25 goes into 208 times, add a 0, so that would be 21 over 80. And I believe that is simplest forms because nothing will go into 21 and 80 evenly. That one was a little bit more difficult just because it required a few more steps. Alright, let's take a look at our next slide. Alright, our next slide is talking about how to convert a fraction to a decimal. And what it's saying is this is giving us an illustration of our fraction right here. Pretend like this is a fraction. And it's telling us how to, well, turn that into a decimal, okay, by dividing your top number here by your bottom number. And a lot of times they say the fraction, the numerator falls into the doghouse. Okay, that's why it's inside the division bar right here. But let's take a look at our next example and I'll show you exactly what I'm talking about. This shows you exactly what we're doing right here. This 11 over 9 right here. If you notice, they took that 11 over 9 and the numerator, the top number, falls into your division box, just like what they have right here. Okay, and then you divide like you normally would. Now on this one, if you notice, they have a bar over this 2, and if you remember from last year, that just means that that 2 repeats itself. This is called a repetend bar. Okay, that means that 2 goes on forever. Alright, let's take a look at the next slide so we can. Alright, this one, same way. Again, your numerator falls into your doghouse, so we're going to divide 7 divided by 20. Now, the first thing that we need to do is we need to add a decimal, and I'll add 2 zeros behind that so we can divide this out. Okay, so once I have that, now I can divide like normal. 20 will go into 7 0 times. I need to bring my decimal straight up. 20 will go into 70 3 times, which gives us 60. The leftover of 10, I'll drop down my 0 here. 20 goes into 100 5 times. So I know that 7/20 equals 0.35. And that's all there is to it, ladies and gentlemen. I think you can do that. Most of you did this last year, so this is a review. Good luck.